Okay, just to recap, here are the 6 properties. I won't go through and read those, but it's kind of nice to have them all in one location, right? Without all the explanations kind of in between. So there they are. Okay, so we are going to look at some examples of simplifying. Typically, we use the first 3 of these properties to simplify, and we use the second 3 to do what we call condense. And really, condensing is simplifying, but it's a special type of simplifying. Okay, so what do we have here? Let's keep this list handy maybe. Uh, Here we go. So we just finished all that. Simplify the logs. So um, we'll use those first 3 in one way or another. We'll see some numbers in play here. What if we start with something real simple? No variable yet. The log of 64 with base 4. Now, this is the kind of question that we got even back in the previous section when we first introduced logs. But now we can maybe think of simplifying this, finding the value in an easier way. So what we're going to do is think about that second property, okay? The log of b to the x with base b. And the property says that this equals x. So if we can, our base is 4, right? So if we can rewrite this with that same base, then our answer will just be whatever the exponent was. So here's what I mean. 64, that's 4 raised to the third, right? So I'm going to rewrite the 64 as 4 to the third. Then I see the same base appears twice, and my property says it just equals whatever that exponent was. So the answer to this one, the simplified version, is 3. Okay, pretty cool. And another way, usually the way people think about it and remember that property is the log base 4 and this exponent base 4 cancel out, and we just have the 3. Okay, so there's that second property in action. How about this one? The natural log of 1. So you might remember the natural log has base e, but that doesn't even matter here. Any log, no matter what the base, if you take the log of 1, you always get the same answer, and it is 0. Of course, we're using that very first property, the log of 1. Doesn't matter what the base is, you always get 0. All right. And how about this? Well, this is going to get at property number 3. Okay. 5 raised to the log of 20 with base 5. And, well, we can get our answer immediately. That property says whatever x is, that's how this will simplify. Really, the way you think about it, this exponent, 5, exponential I should say, that with base 5 cancels out with the log base 5. Exponential base 5, log base 5 cancel out, and our answer is just the 20. Okay, so we've seen those first 3 properties at work. Now let's move on to condense the logs, and of course we'll use the second 3 properties. The second 3 properties really get used quite a bit more here in this section than those first 3, because the first 3 kind of are what they are, but the second 3 we can combine them, we can make them problems a little bit harder. So here's where we're going to start. We're going to keep it simple to begin. The natural log of 3 plus the natural log of 2. So by condense, we'd like to write it simpler with less terms. Okay. So property number 4 talked about adding, right? So if we're adding 2 logs and they have the same base, we can combine them into a single, in this case, natural log, if we multiply the 2 arguments. Okay, so here's what we're going to do, and right there's the property that we're implementing. Here we have natural log in both cases. So it's the natural log of 3 times 2. Well, that's the natural log of 6, and we're done. We condensed these two into a single natural log. There you go. All right, that's that example. Moving along, let's try this one. 3 times the log of 5 with base 8. Well, which property is this going to implement? Well, it's number 6. Okay, we have that coefficient out in front. That's the r, right? So we're going to take that 3, we're going to move it up into the exponent, just like the property tells us. Whatever that number is out there, we can move it up into the exponent. So it's the log of 5 to the third with base 8. And to finish this off, let's actually compute 5 to the third. It's 125. So we've got the log of 125 with base 8. There's the condensed version. So what is condensed here? Well, we don't have a coefficient anymore. We wrote it a little bit simpler. Okay. Let's keep going. Okay, in part C, now we finally have some variables involved. Let's look at 4 log of x base 2 plus 5 log of y base 2. Now we see two things. For one, we're adding these logs, but also they both have a coefficient. So we're going to use properties 4 and 6. Okay, the first thing we need to do is work with those coefficients. Property number 4 about adding does not have any numbers in front of the logs. So we need to move that 4 and we need to move that 5 like so. We have to do that first. Then, once we don't have any coefficients, or you might say the coefficient is 1 in front of both logs, and they're both base 2, we can combine them together if we multiply the two arguments like that. So we've got a single log base 2, x to the 4th times y to the 5th. There's our condensed version. Okay. Got a couple of more of these, actually. Part D. Okay, more variables going on. We've got the log of x plus 1 base 6 and the log of x base 6, and we're subtracting. Well, of course, this will use property number 5. But exactly how? Okay, so, well, we can combine these into a single log base 6 with that divided by that. 1 log base 6, and inside of it, x plus 1 over x. Done. That's all there is to do. I think I've got one more. And you can see these can really grow significantly. Now we have 3 logs. 2 of them have coefficients. Of course, we got variables x, y, and z. These are all the common log, since there's no base written. And if you guys remember, if there's not a base written, it's assumed to be base 10, although that doesn't really come into play in this problem since we're just condensing. Okay, so what should we do first, right? We're adding, we're subtracting, we got these coefficients. The first thing you always do is move those coefficients. We need to do that first. The properties with adding and subtracting never have any numbers in front. Okay, so we're going to put that 3 up in the power of y and that 9 up in the power of z. All right. Then, okay, what do we do now? I mean, we have 3 different parts. I think the most natural thing to do is to just go pair at a time from left to right. So let's combine the log of x with the log of y to the 3rd. If these are being added together, well, that property with adding says, so only looking at those, then we will multiply the arguments a single common log xy to the third. And then we just copy down that other part. Okay, and now we can finish it off. So think of this as a single argument, this as a single argument we're subtracting. So it will become, finally in the end, just one common log, xy to the third over z to the ninth. And wow, I mean, think about where we started and how that condensed, right? And there it is. Okay, so it turns out there is one last idea in this section. You could say this is another property of logs, although it's a different sort of a property than what we were just doing. This is called the change of base formula. So the change of base formula is a really convenient way to use our calculators, really in the end, for things like the log of 103 with base 6. Okay, so what's special about these? Well, nothing really, because I just made those numbers up. What's different about this situation is I cannot write 103 as 6 raised to a power. Right? What power would I put in 6 to get 1? Right, so, you know, that's basically what I'm trying to say is this is not going to be a whole number answer. It's going to be a decimal answer. Okay, so the change of base formula says if you want to know, if you want to use your calculator to compute things like this, here's what you can do. Think of it as the common log of 103 and the common log of 6 and divide them like so. So whatever's in your argument, that'll go into the argument of the numerator. Whatever was your base, that will become the argument in your denominator. And instead of base 6, switch it to a common log, both of them. So I'm just going to grab my calculator here, and I'm going to compute that. So I've got the common log of 103 divided by the common log of 6. And there it is, 2.5866915. I'm going to use 4 decimal places because that's what we see a lot of times for these sorts of questions. 5867. Okay. So it turns out this is actually should be the exponent in 6. 6 raised to the 2.5867 will be, we rounded it, that's going to be just about 103. You could check that in your calculator if you wanted to. I'm kind of curious. I'm going to go ahead. It's super close. I mean, it's a few hundredths off because we had to round. Okay, so if I wanted to know what that decimal version was, I can use the change of base formula to do it. Turns out you don't have to use the common log. You could use the natural log. Okay. Maybe instead, I'm a fan of natural logs over common logs. I could say natural log 103 divided by natural log of 6. And check out what happens when you do that. Natural log of 103 divided by natural log of 6. You get the same answer. 2.58, and I'll round it the same way. And this is really interesting. It doesn't matter if I'd go common log or natural log. The ratio of those two numbers always comes out the same. Truth is, change of base formula is even more general. You could use any other base, right? This is base 10, base E. You can use whatever base you want, so long as you put it in both numerator and denominator of each log. It's always going to come out to that number. Now, so why do we showcase common log and natural log? Because those are the logs in our calculators. So we really want to highlight that because that's what we're going to use it for. Again, this is going to be super helpful in the next section. We might have to round our final answers to things. We want to be able to do that. Okay, I'm going to stop this video here. In the next part, I'm going to show you guys a couple problems, give you a chance to try some out, and then we'll do those together as well.